All right, welcome to our last video for the EOC review. Now, number 58, you're asked to find the surface area of the rod. So all of the surfaces that make up this cylinder. Now, I need to know two pieces of information. I need to know the area of my base, which is the circular portion of your cylinder. And then I need to know the lateral area, which is the curved portion here of my cylinder. Now, the formula for surface area is always broken up into two pieces. You need the lateral area, and then you need to add the area of your bases. Or if you only have one base in the shape of a cone or a pyramid, then it should just be one base. Now, my lateral area formula for a cylinder, it's basically the circumference of your circle times the height of your cylinder, because that would be the area of the rectangle that would be formed. If you unravel your cylinder, it would look like a rectangle where the length here would be your circumference for the circle, and then this base would be the height of the cylinder. So for our lateral area, we're going to write down that to find it, I'm going to do 2 pi RH. 2 pi r is your circumference times the height. That's how you get the curved portion, the pink portion of the cylinder. And now we need to find the area of our bases as well. I have two circles that make up my bases, and they're going to be identical circles. The top and bottom have the same area. So I need to find the area of one of those circles, and then I just need to multiply it by 2. So I'm going to do 2 times the area of one circle, which is pi r squared. And that's going to give me my total surface area, the area of the curved portion and the area of my two circles added together. Now for my 2 pi RH, let's take a look at what I'm going to plug in. 2 times pi times my radius. In this case, my radius is going to be 0.5, not 1. 1 is my diameter. So 0.5 times my height, which is 19. Now, the concept of height is tricky for those three-dimensional figures. Height is whatever connects your two bases together. So in this example, my two bases are the circle on the left and the circle in the back of the cylinder. And so what connects my two bases is that length of 19. That's your height for the cylinder. And if I were to rotate that cylinder and have it stand straight up, then that would be that same height of 19 feet. It just gets a little bit trickier when it lays down on its side. All right, so that's how I'd find the curved portion. 2 pi times the 0.5 radius times my height of 19. And then for the area of the bases, we have 2 times pi times my 0.5 squared. Let me make that 0.5 a little bit bigger. Okay, 0.5 squared. Okay, so now we have a lot of calculator work to do. So in the calculator, we're going to do, starting here, I'm going to multiply all the numbers but not pi. So I have 0.5 times 19 times 2, and I get 19. So I have 19 pi for the curved portion, and now let's take a look at the other one. So I'm going to clear this out. 0.5 squared is 0.25. Times the 2, so it's 0.5 pi. Now I'm going to be adding these two together, so I'm going to combine the 19 and the 0.5, and I'm just going to keep the pi along for the ride. 19 plus 0.5 is 19.5, and then I'm going to bring down the pi. I treat the pi like an x value, so if it was 19x plus 0.5x, I would just be adding the coefficients, the 19 and the 0.5. So that's what I did here. And now my very last step, now I'm going to multiply in that pi of 3.14. So I'm going to do 19.5 times 3.14. And I'm going to get 61.23. Now it says to the nearest square foot, so it does not want a decimal. It wants the nearest foot, whole number. So the nearest whole number is going to be 61. Now be careful, in all of these problems they ask you to use 3.14 as your pi, but on the EOC, unless otherwise specified, you're always using this pi button. Let's see if our answer would be different if I use a pi button. 19.5 times pi is going to be 61.26, so it's a little bit bigger. All right, so it does make a difference, and the larger your numbers are, the bigger the difference is going to be. All right, so let's move on to our last two questions. So for number 59, I've already pulled out a graph, and I've plotted the 2 points that they're telling me about. And now I'm thinking about what the coordinates of my new points could be for my parallelogram. Now remember, a parallelogram has both pairs of opposite sides being parallel. So here I'm going to try and figure out where is C going to be located, because they do give me information about C. They tell me that the length of BC, or rather the slope of BC, is 5/3. So I can use that slope in order to figure out the location for C. So if I have a slope of 5/3, that would mean I'm going up 5 and then to the right 3 when I'm counting starting at B. Or maybe C is to the left of B, and therefore to get from B over to C, which could be below and to the left of where B is located right now, I can go 5 and 3 both being negative, because a negative and a negative will cancel out and it'll still be a positive 5/3. Now, if this is my slope, -5, -3, it's going to allow me to go in the other direction, to count in the other direction, and this is going to be going down 5 and going left 3. All right, now let me go ahead and figure out where these points for C could be. So I have from B, I'm going to count up 1, 2, 3, 4, 5, and then to the right 3. 1, 2, 3. Okay, I'm going to put a point right here. And this is going to be point C, possibly. So I'm going to call it C1, because there's another place C could be. I could have C going in the other direction. So if I go in the other direction, now starting at B again, I'm going to go down 5. So 1, 2, 3, 4, 5, and then to the left 3. 1, 2, 3, put a point. So this could be the second location for C. Those are my two possibilities. Let me look through the lists and let me see if either of these match up. Now C1 is at the coordinate 9, 8. C2 is at the coordinate 3, -2. So let's look through our list, because these are only two options. All right, so for choice A, that C is not one of our choices. For choice B, 3, -2, I like that. So I'm going to keep that as one of my options. Now for C, -1, 3, nope, not going to work. And then for D, 3, -6, nope, not going to work. So the direction they did want us to go in is that opposite direction, from A to B to C. And then the other side of this would look something like, and I'm just eyeballing here, would look something like that. Okay, so your last point should be somewhere around here for your parallelogram. All right, last question. Let's move on. Okay, now for your last question, you're looking for this distance from X to Y. Now, some of you may think XY is a mid-segment. If you remember what a mid-segment is, it's when you have a triangle, and then within your triangle, we have the midpoints of two sides, M and M, connected with a line segment. Now that line segment is parallel to the base, and it's half the length of the base. So if your base was 10, that mid-segment would be 5. Now the vital piece of information that we would have to know is we would have to know that your mid-segment is connecting midpoints. All right, so this is a mid-segment. Most of you may think this is a mid-segment, but if we pay attention to the information that we're given, the 2 miles above Y and the 3 miles below Y means that Y is not a midpoint. So this is not a mid-segment. You can't just do 16 divided by 2 and think you're going to get XY. Instead, we need to break out the two triangles that we have here and think about which pieces match up and then form a proportion. So what I'm going to do now is I'm going to break out the two triangles that I have. So I'm going to break out the top triangle, which is BXY, so it's the smaller one. And then I'm going to break out the big triangle from B to A to C, so the big one, the overlapping big one. All right, so those are my two triangles. Now let's match up the information that I have. So I have XY, which is what I'm looking for. I'm just going to call it X. All right, I'm going to put that X there. Now the bottom side of my big triangle is 16. The right side of my little triangle, that's the 2 miles. And then the entire right side of my big triangle, be careful here, the entire right side of BC is 2 plus 3, so it is 5 miles. Now, if I want to go ahead and solve for x, I'm going to set up a proportion. So let's match some things up here. Let's say x is going to match up with 16. And then the right sides are going to match up, so 2 matches up with 5. Let's cross multiply and solve. 2 times 16 is 32. 5 times x is 5x. So in our calculator, 32 divided by 5 gives me 6.5 for x. So x is approximately 6.4. I said 5, but it's 4. 6.4 miles. That's approximately what it is. So it asks you, what is the distance across the lake? Now, it didn't specify exactly how you need to describe it. It didn't say to the nearest whole number, to the nearest mile. It's just saying what's the distance in miles. So I'm going to write my full answer because it's nice and exact. 6.4 miles is the distance from X to Y. Okay, so that finishes up your EOC review packet. Make sure you try out the other questions that I have up on the class website. There's an entire other set of questions, 100 questions, that you can go through to make sure that you are ready for your EOC. And study that review sheet that has everything from the beginning of the year on it. Now, as you notice, this review sheet did not have transformations on there. And transformations are going to be all over your EOC. So you want to make sure that you practice your transformations. If you don't know how or where to get some transformations practice, just let me know and I'll give you a worksheet. I'll give you that remediation or enrichment worksheet I've given you in the past. Additionally, this doesn't have partitioning on there, so look on the EOC Crunch Time tab on the class website and try out that partitioning section of questions. And additionally, it doesn't have constructions. So look over some of your constructions and what the different steps are to make a perpendicular bisector, angle bisector, how to make a perpendicular line off of the line, how to make a set of parallel lines. So look over all of them just so that you're familiar with them for your test. And that's it.